Basically, this question is asking to find the height of a building where here's the building, and if you're 99 feet away and you look at the top of the building and the angle of elevation right here is 43 degrees 26 minutes. I guess we haven't talked about minutes, but what is 1 minute?
60 seconds.
60 seconds. Yeah, 60 seconds, but also 1 minute is in degrees. What is it?
What?
60 minutes make up 1 degree, okay? So 1 over 60. That's a way that angles are measured. So when you have 26 minutes, you have to convert this as 26 over 60 degrees. And that will require a calculator. So let's see, 26 divided by 60 is going to give us 0.433 degrees. Okay? So in other words, this 43 degrees 26 minutes is same as 43.433 degrees. Because it's 43 degrees plus 26 minutes, and 26 minutes is same as 0.433 degrees. Okay? Now, this part, the height of the building, let's call that x, that's the unknown. Which of the SOHCAHTOA should we use?
Tangent.
Tangent. The reason for that is because with respect to this angle, this is an opposite leg, and this is an adjacent leg, right? And therefore, you have to identify the trigonometric function that involves opposite and adjacent, O and A, and that one is the tangent. Okay? So we now have tangent of 43.433 degrees equal to what over what?
X over 99.
X over 99. And you have to solve this for x. How do you solve this for x? Well, first, multiply both sides by 99. You multiply 99 on the right side, you multiply 99 on the left side, which will get rid of this denominator, and you've isolated x, right? So what is x? X is 99 times tangent 43.433. So let's put that into the calculator. So I'm going to do find the tangent of this angle. And by the way, when you do this, make sure that you're in the degree mode. That will be the main source of mistake on the exam, sadly. Like a student may be using the wrong mode. Yes?
How do you know if it's in?
Yeah, so usually on the calculator, if you look at on the top, it says either DEG or RAD. If it says RAD, you have to change back to DEG. And every calculator is different, so you'll have to figure it out by looking online somewhere, okay? But make sure you do it before you come to take the exam, right? Okay, so you have this times 99. So I put everything into the calculator. It tells me it's 93.7288 something, but it's to the hundredths. That's what they are asking. So you have to round to the nearest. So 8 rounds up to 73. So this is 93.73. And always make sure that you use the correct unit. Here's another word problem for solving right triangles. This time we know it's a right triangle because one of the angles is given as 90 degrees. That means that we need to draw a triangle where C is the 90 degree one. So let's just say this point is A, that point is B, and then you have this point as C. That's the 90-degree one. And let's mark those lengths. So AC is 210. This length is 210. And BC is 497. Now, definitely figure not drawn to scale. According to here, BC has to be longer. But it doesn't matter because at the end of the day, the formula that we will get will be the same thing. Now, the question is to find the angle B. How would you find this?
Tangent also.
Tangent also, because 210 is the opposite of B, and 497 is the adjacent of B, and tangent is opposite of adjacent. So we have tangent of angle B equals to opposite over adjacent. So SOHCAHTOA says tangent is opposite of adjacent. But the problem is you can't just put this into the calculator because you don't know what to put in, right? You only know the output. Therefore, what should you do?
The inverse?
You have to use the inverse because now you need a function which takes the output as the input and gives you back the input as the output, right? So you need a function called tangent inverse. So you put in 210 over 497.
22.9.
Thank you. And you get 22.9 degrees. Okay, here, this looks like another right triangle solving question, but it has a slight twist. So rather than asking for the angle, it's asking for the cosecant of an angle. Let's first draw the triangle to see what it's asking us to do. So just draw a 5 and a 12 triangle. If I say ABC, you don't have to name it like this. You could name it as ABC, but nonetheless, at the end of the day, the answer will come out to be the same thing. Okay? All right, so if I name it as ABC, what is the angle opposite the side with angle 12? So can you tell me what this one is?
B.
Yeah? B, right? It's B. It's opposite of 12. So the question is really asking for B, but more than that, it's asking for cosecant of angle B. Now, one possible approach would be to find the angle B first and then use your calculator to find cosecant. Except that some calculators don't have a cosecant, like this one that I have. It only has inverse. So depending on your calculator, you might not be able to do it that way. And besides, this question can be on the non-calculator side as well. So you might be asked to solve this without a calculator. Okay, so in such a case, how would we go about solving this? The first question is, do you know what cosecant is? What is cosecant? What's the definition of cosecant? It's 1 over sine. Yes, it's 1 over sine, angle sine. So what that means is that we just need to find the sine of angle B and then flip it upside down. That will be the answer for the cosecant. Is that okay? Okay. But then, what is sine of angle B? Sine is, according to SOHCAHTOA, it's sine is opposite over hypotenuse, so opposite 12. Oh, that means we need to know this hypotenuse. Let's first figure this out. So the naming convention is this is going to be lowercase a, that's lowercase b, this will be lowercase c. And we have 5 squared plus 12 squared equal to c squared using the Pythagorean theorem. Some of you may even remember the Pythagorean triples, that's 5, 12, and this side is 13. Or you can do this. It's 25 plus 144, that gives you 169, and then you take the square root, you get c equals to 13. Okay, so we are almost there. So we have sine angle of B equal to since this side is now 13, and sine is opposite of adjacent, you have 12 over 13, and therefore cosecant of angle B is, it's a reciprocal, so what do?
13 over 12.
Yeah, you flip it upside down, and 13 over 12 is the answer. Now it uses the formula SOR. Do you remember SOR? It's really S equal to theta times R. Okay. And the accompanying formula is area is equal to 1/2 SR. It's like 1/2 base times height. Okay. First, what is this formula for? This is when you have a portion of a circle. Right? This is angle theta, and this is radius, the radius. Then this arc length, this length here is given as SOR. Okay? What is the formula? What is this formula?
Area of a sector.
It's an area of this sector. Okay? So the area of this sector is 1/2 base times height. It's something like that. Okay? Yeah. So I'm abusing the notation here. This is really theta, but I read it as SOR, so it's easier to remember. This is really not base times height. It's really arc length times the radius, but I just read it as like area is 1/2 base times height because it looks like it. Okay. All right. So let's suppose that you know these formulas. Let's now think about what 48 revolutions per minute means. So if you have 48 revolutions per minute, oh, by the way, this formula only works if this data is in terms of radians. If you use any other angle, if you use degrees, it fails. Okay, you have to make sure that you're using radians. So when you convert this to get the conclusion as the linear speed in inches per minute, you have to first convert the revolutions into radians. Okay, so what is one full revolution in radians?
2 pi over 60.
Yeah, right? If you have one full revolution, right? If it starts from the 0 degrees and you go all the way around, that's 360 degrees. But if you use radians, this is 2 pi as radian angle, right? So the full circle is 2 pi. So you have to say that each revolution is 2 pi. So what you get is, this is same as 48 revolutions per minute is 48 times 2 pi radians per minute. Or 96 pi radians per minute. Is pi. And of course you can further plug in the value 3.1416 to get the decimal value for this, but let's do that later. Okay. All right, so now the thing is, that's how fast the wheel is rotating in terms of angles. But now you want to know how fast a point on the rim is traveling. Okay. So that means the speed is distance over time, right? So that means you have to know how far this point traveled, which is the arc length formula. So we use this formula now, okay? So we can convert that radians, this much radians, into and plug into radians times, what should I use for R?
5.
Huh?
Is it 5?
No, there's an R here. Where is it? 10 inch, right?
Well, is it isn't the R 5?
Ah, sorry. Yeah, you're right. Yeah. So it says diameter. Yeah, good catch. Okay, so this should be really same as R equals to 5. Right. because 10 is the diameter. All right, thank you. So now what you get is that in 1 minute, 96 pi radians is the angle traveled. Okay, angle traveled. And using s equal to theta times r, where theta is at 96 pi radians, and then r is 5, you get 480 pi inches traveled for that point. Okay? So because this much is traveled in 1 minute, the answer is 480 pi inches per minute, which is a perfectly good answer, but maybe this is in the calculator section and they might want you to, since it's a practical question, they might want you to put the answer in terms of decimals. So what I'm going to do is I'm going to multiply 480 times 3.1416, the usual value for pi, usual approximation for pi, and that gives me, actually, it's about 150,800 inches per minute. So the real value is 150,798. So if you round it to the nearest hundredths, everything carries over, and this is what you get. We have to convert the linear speed into angular speed as revolutions per minute. Okay, so for this question, I guess you need to be provided how many feet is in 1 mile, and then how many inches are in one foot. So
are these questions coming in our exam?
Yeah, it's in the practice exam. So.
Okay.
So
you
didn't
make
problems or something?
the exam?
No, I'm just doing the work problems first, so we can then focus on the other parts.
Okay, but we're gonna be given in the exam that
We will be given the miles in terms of how many feet and then how many inches in a foot. Okay. All right. So can somebody help me out here? How many feet is in one?
I think it's 2,000.
No. That's not. Definitely not. It's
1 foot is 0.00189 miles.
no. I want 1 mile. 1 mile equal to how many feet? 5,000 something.
5,280.
5,280?
Yes.
Okay. Right. I just remember something like 1 mile equals to 17,000 something miles. So that's right. 3. Yeah. What is it? 21, 17, and then 18. 1760 yards. Sorry. So 1 mile is 1760 yards. So that's the one that I remember. All right. So assuming that that's given, let's now try to convert everything. So first, let's work slowly towards to the answer. It's hard to do everything in one single calculation. So we're going to ask, see, 9 miles in 1 hour. So we know this. How many inches in 1 hour? So let's ask that. How would you do this? If 1 mile is 5,280 feet.
Just convert 9 miles into feet.
Yeah. So 9 times 5 to 80 feet is how much you travel, but then to convert that into inches, what do you have to do?
Times 12.
Multiply again by 12. So let's do that. We get 9 times 5280 times 12 equals to 570240. Okay. But then eventually I have to convert that to revolutions per minute. So now I have to ask the following question. How many inches in 1 minute?
60.
What should you do?
Can't you divide that number by 60?
You divide this by 60 because this is how much the child has traveled in terms of inches in 1 hour, right? So you have to divide this by 60. Divide by 60. And you get 9504 inches in 1 minute. Okay. Now we have to convert this length into radius and angles. How do you do that? You invoke the SOAR. Now in the previous question, we were given the angle and the radius to find the S. That's what we were doing. In this question, we're given how much the child has traveled and the radius of the bike, and then we're being asked the radians. Okay, this angle. Okay, so using this, now let's do this. You have 9504 as the value of S. Theta is the one that we want to know. And what should I use for R?
3.
3.
Just divide by
So you divide both sides by 3 to get the theta. So let's see, what's that? Divide by 3, you get 3168 radians in 1 minute. Okay? So if you look for how much rotation was done, you've rotated this much angle in 1 minute. But we're still not done yet. Okay? How would we do this? So this is in terms of angle in radians, but what's the question asking for? It's asking for revolutions per minute, right? How do you convert this into revolutions?
divided by 60.
Nope.
So divided by 2 pi.
You divide by 2 pi because 2 pi radians is 1 revolution. Okay, so remember, maybe I should write it here. 1 revolution is same as 2 pi radians. Okay, so if you want to convert radians to revolutions, you have to divide both sides by 2 pi. And that converts radians into revolutions. So what I do is I take this value and divide by 2, and then divide by 3.1416, and that gives me 504.2 revolutions per minute. Okay? Which, by the way, is somewhat strange. Like, that seems like too fast, right? There's no way a child can pedal that fast. Like if you divide that by 60, it's like 8.4 rotations in 1 second. Can you do that? No, so something's off in this question. So either I think the problem is the wheel size. Wheel size should be much larger than this. But anyways, that's the answer. Okay, for this problem, again, you're asked to use these two formulas, S equal to theta r, also known as a SOAR, and sector area is half times S times r. I just think of it as like half times base times height, although it's not base times height. But the catch here is that for these formulas to work, the angle must be in radians. If it's not in radians, you have to convert it into radians first. So knowing this, and since the question has given the angle in terms of degrees, not radians, you have to first convert it into radians. All right, so how do you convert degrees to radians?
Pi radian over 180.
Right. You multiply it by pi divided by 180 degrees so that the degrees and degrees cancel. Right? It's like this degree and this degree cancels out, and you just have to do 83 times pi divided by 180, which can be calculated by using a calculator. Let's try that. 83 times. Most scientific calculators have pi somewhere. So if you look closely, it's easier to use the pi rather than using 3.1416. So I found my pi, so let me use that. Okay, and then you have to divide by 180. And the result is the following. I get 1.44862. Now I'm trying to use more than 6 or more because this has 5 significant digits, right? So it has 5 significant places, so I want to use 6, and after doing the calculation I will only keep the 5, all right? Okay, so now what? The question is asking for both S and A, and we have everything that's needed. This is going to be our theta. Okay. So we're going to calculate S equals to 1.44862 times, that's our theta, times R, and R is given there, 143.58. So let's multiply that times 143.58, and the result is you get 207.99 something, and then we just keep the 5 because that's what's given here. Okay, so that's your
That's your S.
S. However, you need a unit because the original thing is given in inches. So what should I put in here? Inches. Now we do sector area. Area is equal to 1/2 times this value S times R. And R is again 143. Yeah, I'll just write it. 1/2 times 207.99 times 143.88. So if you multiply this by 140, let's see, 207.99 times 143.58. And then times 0.5, I get 14931.6, and then if you round it to 6 decimal places, 5 significant figures, I get this, and this should be inches squared, because area is measured in square inches, right? So that's the answer. Any question on this?
I didn't see nothing. You only had to find one thing.
Yeah. The only tricky part is trying to figure out the degrees, and the remaining part is just straightforward application of the formula. Okay, so if you are nervous because of all these word problems, we just have one more to go for the word problems, and the other ones won't be word problems, okay? How far is the person above the ground? Okay. So here's a Ferris wheel. here's a Ferris wheel. See, if you have radians, it's a bit hard to picture it. So what is 4 pi over 3 radians in terms of degrees?
240.
240, right? Because pi is 180 degrees. 180 divided by 3 is 60. 60 times 4 is 240. You get that? 4 pi over 3 is 4 times 180 degrees over 3. That's 4 times 60 degrees, because 18 divided by 3 is 6, right? And that's equal to 240 degrees. And 240 degrees is like 60 degrees more than 180 degrees. So let's picture it like this. You have, okay, it depends on which way the Ferris wheel is rotating. And which way do you want it to rotate? This way or that way? Clockwise or counterclockwise? You want clockwise?
Yeah.
Okay, let's do clockwise. It doesn't matter, okay? So if we say clockwise, then 180 degrees would be this much, right? And then 60 degrees more will be somewhere here, right? So if this is 90 degrees, 60 degrees is somewhere here. It's closer to this, right? Okay. Is that okay? You like counterclockwise?
The unit circle is counterclockwise.
So you want the, it's okay.
It makes more sense.
Yeah. All right, at the end it doesn't matter, okay? So you have that, and so you're right here, where this is 180 degrees plus 60 degrees. That's how I'm thinking. So now, the question is, what is this length right here? Okay. That's the question. How high is that? Well, I can divide this into a right triangle and a rectangle, right? And I even know this height, this portion. What is this height?
50 feet.
50 feet. Why? How do you know that? Because that is the radius of the Ferris wheel, right? The couple must have started here, right? And went 240 degrees. If they're here, this much would be the 50 feet, which is the radius of the Ferris wheel. So it's 50 plus. Now the tricky part is, how much is this side? What's this length right here? Well, for this you have to solve a right triangle. So I thought this was going to be another SOAR question, but it turns out to be solving a right triangle question. Okay, so let's try that. Just take this triangle and let's put it right here. Now I need you to figure out a few things. First, what is the length of the hypotenuse?
50.
Huh?
50.
50, because that is the radius of the Ferris wheel, right? So this is going to be 50.
Two sides can have the same length?
This side is not the side of a...
Isn't the base 52?
No, base,
No.
so base is less than 50 because it stops here. The actual radius is this much and the base is this much. Okay, so this side is definitely less. Okay. All right. Now, can you tell me this angle? What is this angle right here?
30.
It's 30. How do you know that?
Because
Well, because this much is 60 degrees and this is a right angle, right? So if you subtract from 90 degrees 60 degrees, you get this much as 30 degrees. Oh, so then we have a nice solving right triangles question, and we just need this value right here. Let's call that x. Okay. How do you find that? Which trig function should we use? Sine. SOHCAHTOA, and we use sine because x is on the opposite of 30 degrees, and this is the hypotenuse. And the only trig function that involves both the opposite and the hypotenuse is sine. So we have sine of 30 degrees, giving you opposite over hypotenuse. How do you solve for x?
Multiply by 50.
multiply both sides by 50. Yeah, if you multiply 50 or 50 there, 50 and 50 cancels, leaving you with just x. And now you just have to do 50 times sine 30 degrees. And if you use your calculator, you see that this gives you exactly 25. Okay, so we're almost there. What's the answer to A then?
75.
75, because this much is 50 and this much is 25. You add the two. 50 feet plus 25 gives you 75 feet. So they are right now 70 feet above ground. That's where they are. That's the answer to A. Now for part B, we have to think about angular speed. So let's think about angular speed. How is angular speed measured?
Soar.
That's a bit, that's when we have the actual linear speed, but we don't have the linear speed. We just have how much angle has turned in a given time. So, angular speed means same as change of angle divided by change of time. Just like linear speed is change in position divided by change in time. The same idea. So how much angle has changed? What's the change in angle as in 10 seconds? What was that? You can answer this in two different ways. If you go with the radians per second, it's 4 pi over 3 radians, right? And this much was turned in how many seconds? 10 seconds.
10 seconds.
Okay. And that gives you, it's 4 pi over 30 radians per second. And you can use a calculator for this one. 4 times pi, and then divided by 30, gives you 0.419 radians per second. But alternatively, you can use degrees per second. So we know that 4 pi over 3 is 240 degrees, right? So you have 240 degrees per 10 seconds. So what is that? That's 24 degrees per second. Okay. Either are valid answers. And if you want, you can even change this to revolutions per second if you want. You can divide this by 2 pi to change it to revolutions. Yeah. So depending on the unit, this might have several answers. Yes?
You would accept either on the test?
On the exam, I would accept either one. Okay, let's start this. In order to answer this question, you should first think about what pi over 6 is in terms of degrees. Pi is 180 degrees. So if you divide that by 6, what do you get?
30 degrees.
30 degrees. Okay. So this question A, part A is saying it's cosine of 30 degrees. Tell me what cosine 30 is.
0.86.
No, this, you're trying to solve this in a non-calculator section. Okay, so this is going to be radical 3 over 2.
Radical.
Because it's the large
Oh.
one, okay?
Like that. Okay, that.
Okay, B. What is secant?
1 over sine.
This is 1 over sine, so you take this and you flip it. 2 over square root of 3. Okay.
No, secant is 1 over cosine.
Yeah, 1 over cosine, yeah. So you take this one and you flip upside down. Okay, and then C, tangent is sine over cosine, right? So you have to do tangent 30 degrees equals to sine 30 degrees divided by cosine 30 degrees. And that's going to give you, sine 30 degrees is what? 1/2. And cosine 30 degrees
You
is?
already know it.
You already know it. 2 over square root of 3. No. 3 over square root of 3 over 2. Now how do you simplify this? You simply have, yeah?
Cancel 2.
Yeah, you multiply 2 top and bottom to cancel the 2 in the denominator. So you end up with 1 over square root of 3. Okay, and then finally, what is tangent of negative pi over 6? This one, you could use the formula sine negative 30 over cosine negative 30 and figure those out separately. But there's an easier way. If you look at the 30 degrees and negative 30 degrees, this is positive 30 degrees and negative 30 degrees. That's negative pi over 6. You go negative 30 degrees is you go clockwise 30 degrees, so this is where you land. And what's the geometric meaning of the tangent?
Slope.
It's the slope of this ray, right? So if you have a ray going this way and you have another slope going down, but in the same amount of slope, this slope will be just negative of this other one. This has positive slope, that has a negative slope, right? So this will be tangent of negative of an angle, it will be negative of tangent of pi over 6. By the way, here are some more tips. For the sine, the same thing happens. If you have negative of an angle, this can be pulled out and you get sine of negative of sine theta. However, for cosine, it turns out that the negative doesn't matter. Okay? Cosine negative theta is the same as cosine theta. You can, if you have a calculator, you can check this by plugging in some numbers and you'll see that sine of a negative is the same as negative of sine of that. Whereas if you have, say, cosine of negative 2, put your calculator in radian mode and put cosine of negative 2 and compare with the cosine of 2, you get the same exact value. Okay? Is that okay? Alright. So that's a handy thing. And now let's read the question again. Which of the 4 listed numbers is the largest? Okay, definitely not the negative one. This will now become negative of 1 over square root of 3. So that's negative. That will be the least of all the numbers we have here. Okay, so that's out of the picture. Now we just have to figure out which one of these. Now here's an obvious question. Which one's bigger? Huh?
Between those two?
Between these two.
B.
B, because this is twice of this, right?
Yeah.
Okay. So now the question is, which is bigger? Is this one bigger than this, or which one do you think is bigger? B is bigger?
No, A.
No.
So how would you know that? So that
Well,
Multiply that
that's values of the larger one, so.
here's another way to think about it. See, square root of 3 over 2 is same as square root of 3 over square root of 4. Is this bigger than 1 or less than 1?
Yes.
Less than 1, right? But on the other hand, if you have 2 over square root of 3, this is square root of 4 over square root of 3. Is this bigger than 1 or less than 1?
Bigger.
Bigger than 1. So now which one's bigger? This is bigger than the other one, right? Okay. So this would be easier if you knew that cosine is always between negative 1 and 1. And because secant is, you're taking the reciprocal, secant will always be bigger or equal to 1 or less or equal to negative 1. Okay? So that's another fact. It just comes from the fact that if you have a number between 0 and 1, you take the reciprocal, you get something bigger than 1. Right? So this is something that you get. Okay, second question. Find the function with period pi over 4. A few of these are easy. what is the period of cosine theta? Sines and cosines are what we know as periodic functions. Why is that? Because they are tied to the unit circle, and the values on the unit circle will repeat every 360, or in radians 2 pi. So 360 degrees is 2 pi, right? So I know that cosine would have a period of 2 pi. On the other hand, for the tangent, we've talked about this in class, but you might not remember. What's the period of the tangent? It repeats every 180 degrees, or pi, okay? So that's a bit exceptional, but both cosine and sine is going to repeat their values every 360 degrees. You get that? Okay. So I know that this has a period of 2 pi, so that's easy. Now for part B, we have to know what this 1/4 in the front is going to do. What does this 1/4 do to the graph? So to help you out,
The period?
here's the graph of cosine. So cosine, you draw the cosine by first marking the 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. This point is 3 pi over 2, right? And the graph of cosine goes like that. What is this value? 1. Okay, what is the minimum? -1. That's the graph of A, right? Okay. Now if you put a 1/4 in front, what's going to happen to this graph? It compresses up and down, right? So by the way, this thing is just one period. It repeats itself, right? So this thing repeats itself again and again, left and right, so that it's a periodic function. And if you compress just the y-axis by a quarter, so this will be same as this, but instead of approaching 1 here, it'll be 1/4 and -1/4. Okay. What's the period of that? Period is about what's the length of x to repeat itself, right? Huh?
Half pi.
No,
Pi over
it's
2.
still 2 pi because it only compressed on the y-axis. It didn't change anything on the x. Is that okay? Right? So because of that, this still has period 2 pi. It never messes with the x direction. Okay. But then now you have C and D. These require a bit more analysis, right? We have to know how to draw these things. Okay. And therefore, we're going to approach the C and D by the method that we did in class, which is to think about the values which this gives you the 5 important points. So I raised the cosine, but it's 2 pi, pi, pi over 2, and 3 pi over 2, and then 0, right? So when the cosine is evaluated at these 5 points, you know the exact values, and it enables you to draw the graph. So what we're going to do is we're going to say, when does 1/4 of theta get equal to 0? And when does 1/4 of theta get equal to this, 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 this? And then later on, I kind of explained that you don't want to do all 5. It's just taking too long. So instead, what you do is just do the beginning and the end, right? So 1/4 of theta is 0, and 1/4 of theta is 2 pi. You do that. Now, if you solve this, what do you get? You get theta as? You multiply 4 both sides. What do you get? Theta as?
1 pi. -1 pi. I mean,
No, I'm multiplying 4 both sides. What do I get?
oh,
0.
0. Okay. And then if I multiply 4 both sides, what do I get? Theta is?
8 pi.
8 pi. So what you get is, now, here's 8 pi, and then you have this. What's the period?
2.
No, 8 pi is the period.
Two
Okay?
times.
Same thing here. 8 theta equals to 0, 8 theta equals to 2 pi. And if you solve this, you get theta equals to 1/4 pi. So this one gives you 1/4 pi, and you have the same cosine graph. What's the period here? 1/4 pi. So the answer is D.